Hi, you are welcome once again to the Smart Way lectures on the Science Ambassador series. This is a series of lectures we are running on all the areas in science, and today we are going to help you to determine the standard enthalpy of solution experimentally. We are going to do the experimental determination of standard enthalpy of solution. Now, quickly, we said that standard enthalpy of solution is the amount of energy absorbed or liberated to the surrounding when 1 mole of a solute dissolved in large volume of water in such a way that further addition of water does not lead to any change in temperature and energy as standard conditions. And so we define like that. Now today we are going to look at how we can practically measure it. Okay, we can practically measure it. Now I've always told you that to do that you always have to start with the end in mind. How is the calculation going to look like? Always start with the end in mind. Now what are we going to end with? We are seeking to calculate this standard enthalpy of a solution. This time around we are using sodium chloride, okay? And so we are going to do that. And so we define it as the heat either absorbed or liberated when 1 mole of a solute dissolved in a certain volume of water. And so since we are going to dissolve it in water, there is some amount of energy that will either be liberated or absorbed, and so we have to be able to quantify that energy. So here we are going to take what we call the heat, okay, absorbed. So we are going to look at the heat absorbed, that is if it absorbs heat, or the heat was liberated, because there are two types of salt. Some salt will absorb, some salt will liberate, and so we are going to get heat absorbed or liberated. Okay, now you divide it by the what? By the mole. You divide it by the mole of the solute. Divide by the mole of what? Mole of solute. Divide by the mole of solute. So mole of solute. And we know that heat is given in joules, and then this is given in what? In moles. This is given in moles. So that means our final result, we are going to get joules. We are going to get what we call joules per mole. Okay, joules per mole. And because the values will be too big, we'll strike it by kilojoules per mole. So how are we going to do this experimentally? Very, very simple. These are your apparatus that you are going to use. We are going to use your chemical balance. We are going to use the thermometer. We are going to use your beaker. The water and then the solute are also constant. So this is what we are going to use. So first of all, you measure a certain volume of water in a beaker, in an insulated beaker. Measure a certain volume of water in an insulated beaker, and then you take the initial temperature of the water. That is, say, T1. Okay, take the initial temperature of water, and then you now add what we call the mass of the gram. You have what we call the mass of the what? Of the solute. So you add what we call the mass of the sodium hydroxide. The mass of the sodium chloride. So you add the mass of the sodium chloride, and then you stir to make sure that it dissolves completely. Okay, now please, this is very important, because if it doesn't dissolve completely, upon further addition of water, there is some amount of energy or temperature that will change. We don't want that. We want the salt to dissolve in the given volume of water completely, in such a way that further addition of water does not lead to any change in temperature. Have you gotten that? So please, when you add the mass of the salt, okay, to the water, make sure that you stir completely to allow maximum dissolution. Okay, and then the next one is to record the final temperature. So you record the final temperature, say T2, and then after you do that, you now go and determine the mass of the content. You have to weigh it again. Weigh the whole beaker containing the salt solution now, and weigh it again to determine the mass of the content. But this is a very simple thing, so we are going to help you through the calculations. Okay, the theory we are going to use is based on the fact that the heat that is absorbed, the heat that is liberated during the process is the same as the heat what absorbed. The heat that's going to be liberated during the process is going to be the heat that will be absorbed by the water. And so we are going to use the absorption energy, okay, to be able to calculate the heat that is going to be used. So quickly let's look on the board and then do the calculation quick. So let's look on the board now. The calculations, we are going to do calculations. We are going to do calculations. Okay, so we are going to run the calculations. And in these calculations, we know we have it in mind already what we are going to do. We have that in mind already what we are going to do. We are going to measure the heat, and I've told you that in our previous video. I told you that the heat is always the specific heat capacity times the mass of the given medium times the change in times the change in temperature. But because it is enthalpy, it is per a certain mole of substance that is either involved in the reaction. And now I have my specific capacity of water. So here you assume that the specific capacity of water is this, okay, to be that one. And then we have our mass of water. Our mass of water will be found by weighing. Okay, you can weigh the water before you start the reaction, or you can weigh it afterward, after the reaction. But this is a very simple thing because we are using only the water. Okay, we are determining only the mass of the water. Okay, the reason why we are doing that once again is that when the salt dissolves in water, it liberates energy to the surrounding. Okay, it liberates energy to the water, and the water pick up this energy, and so we are going to use the energy, okay, absorbed by the water, okay, to be the energy liberated from the reaction. Okay, so that's what we are going to use. And so we are trying to determine the mass of the water, and the mass of the water can be determined and the mass of the water can be determined, okay, just before weighing. Okay, and the mass of water can be determined by weighing, okay, by weighing the whole thing after the experiment. Okay, or we can determine it experimentally. Okay, how do we determine it experimentally? We know that density, okay, is equal to mass over what? Mass over what? Over volume. And so mass is the same as density times what? Times this. Okay, so if you don't want to weigh it experimentally, then you can do your calculations. Okay, you can do your calculations. Now quickly, then it means that if I want to do calculations, it means that I'm going to use the density of water times the volume of water times the volume of water. That will be my mass of my water. So that's the mass of the water. And then the change in what? In temperature. And no, of course, the change in temperature is what? Is T2 minus what? Minus T1. Okay, T2 minus T1. And then we are going to also help you to what? Calculate the mole of the solute. Okay, the mole of the solute. How do we find the mole of solute? It is mass over what? Molar mass. Mass over molar mass. And in the setup, we use M mass. And so you divide by the molar mass, which is what? Big M. Okay, so this is what we call the molar mass of it. And so quickly you come back to insert the figures. You come back to insert the figures. So we are determining the standard enthalpy of what? Of solution of what? Sodium chloride. The name of the compound is sodium chloride. And so we are going to determine the heat absorbed by the what? By the water. The heat absorbed by the water over the mole of what? Over the mole of solute. Simple. That's what we are going to use. And so we have the specific capacity of the water multiplied by the mass of the water, which is now the density of the water times the volume of the water, times the volume of the water. Okay, then times the change in temperature, which is what? T2 minus what? T1. Okay, that is T2 minus T1. And then I'll divide it by the what? By the mole, which I now know that the mole is what? Small mass over what? Over big mass. Okay, so this is how to determine it. So this is the formula. So this is the experimental determination. First, what we did was to what? Pour a certain volume of water inside a beaker, and then we measured the initial temperature, and then we poured a mass, that is m gram of the solute into the water, and then we measured the final temperature. We reweighed the whole setup to determine the mass of the content as the mass of the water. Okay, to determine the mass of the content as the mass of the water. Or we can also do some calculations on it. Knowing the volume of the water, we already know the density of water to be 1, so we can just use these calculations. Okay, so that the mathematics is always follow like this. Always you have to begin with the end in mind. How is my mathematics going to look at? What theory is will help me to do the calculation? The theory is that heat absorbed or heat what gain over the given mass or mole of the solute. That is what it is. Okay, and so the heat absorbed by the water during the dissolution, okay, over the mole of the solute. And so if the heat, then it means that the calculation we've done that already, that heat absorbed is the same as the specific capacity of the medium that absorbs the heat times the mass of the medium that absorbs the heat times the change in temperature of the medium that absorbs the heat over the mole. And so this is the calculation that's what we have done. It's a very simple thing to understand. Very simple thing to understand. Good. So we'll end our lecture here, and in our next lectures we'll take you through the standard enthalpy of hydration. We are also going to take this on a detailed level so that you can appreciate and understand the subject. Thank you very much.